To solve question 2 regarding the garden example on Desmos, then I first need to enter my equation. I'm going to type mine in intercept form, but you could also use standard or vertex form if you have those. If you want to, you could turn on the projector mode if you want bolder lines. And I can zoom in, move my screen around until I see the entire graph. But sometimes when I do that, that's frustrating because I don't like the window that it's using in order to show that. On Desmos, you can also set the window yourself by going to the graph settings again and typing in a different number for the X minimum. I'm going to use -10 and 80 since those are two numbers that allow me to see my intercepts of x equals 0 and x equals 70 very nicely. Notice the y-axis scaled as I adjusted the x-axis. We're asked several different questions, one of them being what is the maximum area? And recall that all these ordered pairs on here are saying if you set the width of the fence to be 0, the area will be this number. In our case, 0 here. If you set the width of the fence to be 5.62, the area will be 361.816 square feet. And we can see all of these different numbers as I change the width. Of course, the length changes out as well, represented in our formula. And I eventually reach my maximum value of 1,225, and in this case it would be square feet. That is the largest garden you can make given these parameters. Any width that you use that's larger than 35 begins to decrease the area all the way until we let the width be 70, meaning that there's no fence left to make a length, and therefore our area is 0. So the two ends here, the 70 and the 0, are the extremes. Everything else along the way is possible. So the maximum area was 1,225, and that happens when you let the width of the pen or the fence be 35. The other question that we're asked is it possible for the garden to have an area of 1,250 feet? That is not possible because I can see right here the largest value is 1,225. The remaining question asks us for what widths is the area greater than or equal to 825. I'm going to go ahead and show that visually by typing in 825. And I know that this intersection point here is the first value of x for which the area is 825 as desired. Then anything after that, any point along here, is going to have an area greater than or equal to 825. Here's where we peak again. And then we begin to decrease our area as my width gets larger than 35, and the area stays above 825 until I reach x equals 55. And at x equals 55, my area is 825, and then anything after that is less than 825. So for question B, I would say from x values of 15 through x values of 55. In part E, I'm reconsidering my equation so that my 140 is only used to fence 3 sides. So my equation switched a bit. I'm going to edit this equation to say x multiplied by 140 minus 2x, and I can see that my area has potential to be larger, and I'll go ahead and keep this window. That's workable. And you can see by changing the restrictions and only having to fence 3 sides, we have the potential for a much greater area in our garden. On F, the only thing we're interested in is the maximum value. And I can see, again, setting the width to be 35 is the magic number, but this time the area is 2,450. There's a variety of other things that we could ask. We could certainly say, for what value of x does the area hit a certain target? what would we need to do there. But typically, in a problem like this, you're looking to maximize or minimize the situation. In our case, maximizing is the task that makes sense.